the presentation. And just as always, if you're not part of a WhatsApp group and want to join the WhatsApp group, let me just add the link to the WhatsApp group so that you guys can join the WhatsApp group if you're not part of it. Okay, so what we're going to do this morning is we're going to look at study unit 8. So we start preparing for your next assignment. So study unit 8. Then on Tuesday, we're going to do a recap of study unit 8. On Thursday, we'll start with study unit 9. And then next week, Sunday, do a recap of study unit 9. And then hopefully on Tuesday or Thursday, we will do our first prep on assignment 4, that we look at previous assignments, or one of the mock assignments that you guys might have. Okay, so basically today we're going to look and start with confidence intervals. And what this entails is we will look at confidence intervals for 3 things. So nearly building up from chapter 6 and 7. So when we look at the confidence intervals, we've got confidence intervals for what we did in chapter 7 for the mean. And remember, in chapter 7, we also looked at proportions. So that is going to be our first decision when we look at questions. Are we working with a mean? Are we working with a proportion? And then basically why it is free is because there will be in the question information about the standard deviation. So if your standard deviation is known, we follow the normal process with a X and a Z. If your confidence interval is where your standard deviation is unknown, then the process will still involve the mean, but instead of a Z, we are then working with a t distribution. Okay, so that's a big difference that we're going to have in this session or section compared to chapter 7. So in chapter 7, we only looked at the mean and the proportion, where at the top level we use Z's for both. Now we're taking a step further. So if your standard deviation is known, we still work with a Z. If your standard deviation is unknown, we will venture into using a T. And again, T distribution, you will, or you have the tables. I'll show you on the tables how we use it. And with a proportion, it is exactly the same as it would have been with a mean. We go to a Z table and then we work out what is needed. Okay. Important nearly for a confidence interval of a proportion and the one that is known. There we're gonna use mostly this set of criteria for the Z. So they tell us, and with confidence intervals, we will always work with a, why didn't that now? Just quickly. So with confidence intervals, we will always look at two-tail. When we get to hypothesis testing, then they will need to tell us if something is one-tail or two-tail. But confidence intervals, two-tails, because we always look at a confidence between a lower confidence level and an upper confidence level. So when we work with the Z, for the mean that is standard deviation is known, or for the Z um, of a proportion, if they tell us we're working with a 99% confidence interval, we can use that value of 2.58 for Z. If they tell us 95, which is the most used one nearly, we can use 1.96. And if they tell us 90, we can use the 1.645. Okay, so I'll show you as we go through some of the examples how we do that. Then a nice basic thing to remember around the steps of this chapter. So there's a few things that you will get to work out the answers. So they will normally tell you what the sample mean is. They must tell us if that standard deviation is known or unknown. Okay, so that's a critical one to look out for. They must tell us if a standard deviation is known or unknown. We will work with a sample size because in the formula you guys see there is a sample size. And then we will need to work out a critical value. But the critical value is aligned to what we have in this table. Okay, so the critical value will be aligned to this table. And I will probably copy this table every time that we do a sum. Okay, one other thing nearly to remember. So this is the mean that they need to give us. That one is your critical value. That is 1, that is 4. And then remember nearly from chapter, now I need to think, chapter 6, if we did it already. If it was chapter 6 or chapter 7, remember this was the standard error. But your standard error is basically then a combination of 2 and 3. Okay, so that is nearly, if you look at the steps, how to work out the confidence intervals. You've got your step 1, you've got your step 2 and 3, where you work out your standard error, and then you've got your Z or your critical value that you define. And that is basically how you will work out your confidence levels or confidence intervals. And it doesn't matter if it is for a standard deviation that is known or unknown, or for proportion. We will use this typical setup. Again, from study unit 7, we know that the standard error for proportion looks a bit differently. So we will just use that standard error. But again, we will see the difference now. So the only thing that changes in this process is nearly which formula you're going to use in step 5. Okay, so this one was for standard deviation known because they tell us it's a population standard deviation. So then we follow this process. If it is standard deviation unknown, then the only thing you will see now, we use the different standard deviation formula. So instead of population standard deviation, we use S for the sample, and instead of the T, the Z, what we bring in is your T distribution. Okay, so in your T distribution, what is important is we will need to work out the degrees of freedom. And the degrees of freedom is just your sample size minus 1. So we still need a sample size. And that is sometimes where the difficulty comes in the study unit, is that they give you all the same information, and then instead of doing a Z, one does a T, you get your answers. It is mostly wrong, but there is an answer set for you as well. So that is nearly the biggest area of this study unit where students make the mistake, is to all think that the standard deviation is known and you work it out with a Z, or where you think it is unknown and it isn't, and you work it out with a T. So just be very careful with that. I will show you again in the examples what to look out for, so that you can make sure that you classify it correctly, so that you use the correct formula. Because again, this then at step 5 is the only thing that is nearly different. And then the third one that we will look at is the proportion. So again, you can from study unit 7 see that this is the standard error for proportion. So whatever our proportion is, we'll use the Z as we would have done for the mean and the standard deviation that is known. So that process follows the same. We'll use the Z table. We can use those that is in the slideshows, because again, in the exam, you will not get a 98%. You will get a 90, 95, or 99% confidence interval. Okay, so you don't need to worry that in the exam you will now suddenly get different. In the exam, it is clear it will be one of those 3. It might be a bit different in your assignments, where they want to test you a bit on this, but in the exam, you will most likely get a 95 or 90% interval, but they only use these 3 for your exam questions. Okay, so let's start. So just quick recap. We basically doing 3 different types of confidence intervals. The one is where we look for the mean. where we look for proportion, and then the mean can be split in two, where the standard deviation is known or the standard deviation is unknown. Okay, so that is nearly the process that we will follow. So let's get into a few examples. Okay, so, and I will nearly highlight the things that is important. So the Department of Basic Education, earlier findings from a survey, 150 learners suggest an average travel time. There's our mean from home to school at one of the schools of interest. Assume the population standard deviation of learners' travel time is 72. Conduct a 95% confidence interval for the population mean and choose the correct answer from a list below. Okay, so first thing is population standard deviation. So your standard deviation is known. Okay, so with that, we will work with the Z table. Okay, so that is one thing sorted out. 95%. So 95% for Z is 1,96. So from that table, Z 95%, 1,96. Okay, I just want to show you guys. So in the tables, so let's go to the Z table. Let's make it bigger. So we want to find 95%. So let's check. Okay, so there's 95. So if we were doing a two-tail, it would have been 1,65. Okay, so if we did two-tail for 95, 1,65. Okay, so just to show you, you can get it from the tables as well. Okay, so 95% for confidence interval is we're working with a two-tail is 1,96. So let's write down that formula and let's see what else we need. We've got the standard error. Okay, so we've got the X that tell us, where is it? Learner suggests an average time of 114. Z is 1,96. They told us the standard deviation is 72 and the N is 150. Okay, so that will give us unfortunately, some decimals. but that's fine. We can work it out with a calculator. So square root of 150 is 12,24. So 72 divided by that, I get 5, let's just write down, times 5,8788. And probably it is, if you go on 87878787 or something like that, but 5,8788 times 1,96 gives us 114 plus minus 11 point, and they round it off to 2, so 0.52. Okay, so that is how we will work it out. We will now need to plus and minus. First thing I just want to, and it's again just a check. So I know that my number in the middle must be 114. When I subtract something, I add something, but 114 will be in between those two. So I'm just checking, yes, it can be in those two. Yes, it is, because, so for all of these, it seems like 114 can be in the middle. I just do that sometimes, because it can be at some of your options is not like that. So unfortunately, none I could eliminate. So then 114 minus 11.52 gives me 102.48. Check. Okay, so there it seems like it's only going to be that one, but let's just make sure that we then say 114 plus 11.52, which gives me 125.52. Okay, so that is then option B. Okay, so again, let's just, if we go through the steps, we've identified the mean, 114. We have identified that it is a population standard deviation. So that means it is known. We've got the sample size. We've got the confidence interval. So 1, 2, 3, 4, 5. 6 is, or 5 is, we work it out to get to the 6 steps of your answer. Okay, so that is again nearly the process that we will follow every time with these questions. Look at it, analyze it, check if you have a mean, check if you have a population standard deviation or a sample standard deviation. If it is population standard deviation, it is known. If it is sample standard deviation, it is unknown. Okay, so just again, that is for the two differences. The one will be population, other one will be standard, or sorry, sample, or they might just say the standard deviation is unknown. Okay, so we will see now in the next few questions as well how they phrase it. So for this one, they talked about population standard deviation. So population standard deviation is a clue for us that the standard deviation is known. Okay, now let's go to the next one. It looks very similar, but let's just make sure. Okay. Consider the following application exercise from a previous assignment. Most of the school reported decline number of absence following education department's learner program. In a sample of 150 schools, 114 schools, so again, it's exactly the same things, reported a decline in the number of learners absent. Construct a 90% confidence interval for population proportion. Okay, so actually exactly the same information. The only thing is now we're working with a population proportion and not the standard deviation. So I really don't know this off by heart. So, and that is why you guys are also writing open book and can have all these resources that we're actually working through as part of the things that you have at hand. So that is our formula that we need to get to. So let's see what we have. So proportion we have, but we first need to work it out. So the proportion is 114 divided by 150. So let's just work that out. I don't want to work with fractions. Okay, so that is 0.76. Okay, so that number is going to be 0.76. So what, again, even before we go on, 0.76, it seems like it can be between those two. Yes, yes. Okay, there's duplication. Yes, there's duplication. So in this one, we had obviously a mistake in this assignment when it was online about 2 or 3 years ago. There was duplication in answers. Okay, so Z of the proportion, we can read off the table. The Z 90% confidence interval for two-tail 1.645. I'm going to use 1.645. So that is sorted. And then we just need to work out the proportion part. That is divided by the 150. Okay, so you can see, again, similar process nearly, the mean, the Z standard error. So that, again, you can see from previous chapters, that is the standard error that we're working with. So let's work out the standard error first. 0.76 times 0.24 is 0.1824. That divided by 150. So let's just add the step for you guys, and for everybody watching it later. So that is a multiply. So when I work out that underneath to 0,0012, and then if I take the root of that, it will be 1,645 times 0,0349. Okay. Okay, cool. So 0,0349 times 1.645. Very small. I hope this works. 0,0574. Okay, so 0,76 minus that gives me 0,7026. Okay, they round it off to 3 decimals, so that one will be the decimal. So let's just check the top one, so that we just make 100% sure. So 0,76 plus 0,0574, it is 0,817. Okay, so again, following the process, we've got the proportion, we've got the confidence interval. Because it is proportion, we know that here we don't need to worry about a T or Z. Proportions is always working with a Z table. So we know that that was our sample, that was the proportion that we work with. That is the part of the steps that we work out to get to your final answer of 6. So what I'm just doing is just following this process nearly for all the questions that we are doing. Okay, so again, this one we identified it as a population proportion. So we've done now one that we know the population mean is known. We've done one that population proportion. So sure, this is very, very small. Let me move this one to the last one. Okay, so that is theory questions. Okay, so let's look at this one. So again, this was from a previous assignment. Very bad copying from it, but let's read it, and I will highlight the things that we need to. So you can even see it. So Mr. Navarro, the social scientist, took a random sample of 30 adults with autism spectrum disorder and found their reading time to be normally distributed with sample mean and sample standard deviation. Okay, so that's sample mean, that is sample standard deviation. And then they ask us to work out the 99% confidence interval. Okay, so step 1, got the mean. Okay, so that is step one. The mean is 90. Step two, so let's see, what was step two? Let's look at the standard deviation. The standard deviation is 18. So that is fine. Standard deviation is 18. We've got our sample size of 30. So that will be your standard error. But Z or T? Okay, so sample standard deviation tells me that your standard deviation is unknown. Okay, because it's not a population, it's a sample, so standard deviation is unknown. Unknown, we will use T. So now we need to look at a few things. We need to define T as your degrees of freedom, and we will need to get a confidence around that, or use the confidence interval. So, and you guys can go and check afterwards if you used the 2,58, then will probably be an answer for you. But now we will need to look at what is actually this T value that we need to use. So again, tables. Let's just make it smaller first. So we're not using the Z table. We're using a T table. So there it is. Degrees of freedom already. Here I talk about degrees of freedom. So remember, degrees of freedom, how we work it out is n minus 1. So that is 30 minus 1 is 29. Okay, so we will work with 29. So if, let's just see if there's a better way to underline. Hopefully it works. And it doesn't want to underline. Okay, so we can use any of those ones if we don't know yet how to get to that alpha that we're going to work out with. So let's again look at what they give us. So they tell us we're working with 99%. So to work out for alpha is 1 minus 99%, which is 0,01. So that is the alpha. So if it was 95%, it would have been 1 minus 95%, which would have given us 0,05. And then out of this formula, remember, we need to divide that by 2. So we sit with 0.01 divided by 2, which is 0,005. Okay, so the degrees of freedom, or the T that we are looking for, is T29 at 0,005. So that will be the T that we are looking for. So T29, 0,005. We will be sitting with 2,7564. 2,7564. 2,7564 will be the T that we will be using. And let's just check 18 divided by the square root of 30. So if I'm all right, that is 3,2863. So 3,2863 times 2.7564 gives us a 90 plus minus 9,0585. So let's just quickly check again. 90, yes, it seems like 90 will fall within all of them. So 90 minus 9.0585 gives us 80,9415. Let's hope. Don't get the answer for that. That is not great. So did I do something wrong here? Let's just quickly check again. Yes.
So good morning.
Mornings.
Yes, I'm super confused. I would like to know something here. Is it so? You'll correct me, right? If the sample size is greater or equals to 30, we use the normal distribution. But then it said in the somewhere that if the sample size is smaller or equals to 30, we use the true distribution. My question is, how do I determine if this 30 that I see here, or is it because it told me that we use the normal distribution? I'm confused.
Yes. And that is so the first thing that you nearly look at, and that one confuses me a lot as well, is you nearly first need to look at if your standard deviation is known or unknown. So that's nearly your first point of call, is to say, is it standard deviation of a population or sample? So if it is population, then only you use the sample size to say, okay, now we need to actually use a T or a Z. So
Okay.
you don't pick firstly on sample size. That
Okay.
is so, and I think that is also important when we look at the steps. So we first identify the standard deviation and then the sample size. So
Oh,
that is
okay.
nearly also a way to remember it. Um, they normally won't, I don't want to say won't, they might in your assignment do something like that. But in the exam, it will be clear if you need to use the T or the Z. So they won't in the exam do the sample size thing and then a standard deviation that you nearly need to. So from that point of view, they might in the assignments test you a bit to see if you understand the difference in those two. But in the exam, it will be straightforward. They will tell you it's known or unknown so that you know that which one to use.
Okay. All right. Thank you so much.
Cool.
All
I
right.
just now want to find out where did I make the mistake in this one. And I hope that is 18. Just very close to 89415, 84.2. Let me just see if I somewhere, and it might be with a rounding off even, that I've made a mistake with this. So 3,2863. Seven, 5, 6, 4. Is that? Yeah. Okay, well, answer needs to be 2. So I'm just worried that somewhere that does look like 30, and that does look like 18. So the answer should be option 2. So very close to the 80.94. Just worried about that 1.5. So let's quickly check if I put in a online calculator, because it might just now be with the T table. So let's say I want to work out the T score. So let's put it in here. Okay, so we set the degrees of freedom was 29. That was and at alpha it was 0.1. I just want to check, or did we say 0.01? 0.01, because it was 99%. Okay, so they're just working out the T value. They're not working out the, let's quickly check, 2.75, 2.7563. and I had 2,7564. Okay, so I don't be interesting. I'm just checking so we know at least that is right. Let's just, for interest sake, say 3.2863 times that value, 2.75. It should not be that big a difference. If I look at my answers, it really should not be. Yeah, I know it's weird. Okay, so I'll just go and check this one again, but the right answer is option 2. So just in those last, there's some mistake. If we look at the top one, it will be 99,0585, which again, up until there, it is fine. So it's just those last, what is it, out with 0.0014. Sheesh. So that can be anywhere in the calculation with that. So again, in the exam, this was again an assignment question. So in the exam, or even if your assignment again is something like this that you don't get, you let me know, and like in the previous one, they will take away the question or correct it so that you don't lose the points. Okay, so let's look at the next one. So they might also just ask you to work out a lower confidence level or an upper confidence level. So that it seems weird when we talk confidence intervals, but now you only see one number. Okay, so here they ask us, and now again, this might be where it's different for different papers. So they can, for some, ask for upper, for others they can ask for lower confidence. So in a random sample of n 1,000 observations, we found that the proportion of success is 0.48. Okay, so that is your P. The upper confidence limit for the 95% confidence interval for the proportion is. Okay, so we've got 0.48 plus minus Z is 1.96 because that is 95. And then, I can't remember. So again, it is what? P1 minus P divided by N. So P1 minus P divided by N, and we take the square root of that. Okay, so just before we nearly start with anything, remember confidence intervals. So we're looking for the upper one. The upper one will be more than 0.48. Okay, exactly 0.48, probably not. Okay, that is not more than 0.48. 0.15, no. 0.449, no. So even before we started off with calculating, we only actually have one answer. But let's work it out just so that we see what we get. So 0.48 times 0.52 divided by 1,000. So that will be our standard error, which we will multiply by 1.96. So let's just see what is that standard error. So 0.48 times 0.52 divided by 1,000, and then shook a square root of that. So I get 1.96 times 0.0158. Okay, so if we multiply that by 1.96, look now at this. Interesting. Okay, so if I ask us the standard error question, or this component of a question, there is an answer for you. So again, if you just, as you work and you see an answer, so working out this component, there is an answer for you. Okay, so if we then add it to 0.48, we get that our answer is 0.51. Okay, which is option 1 in the end. So again, just be careful also in what they might ask you. So they might still have asked you to work out standard error. So even with confidence intervals, just remember every time this component in all the formulas, if you go back to study unit 7, is your standard error. So they might even ask you a standard error calculation, even though we want to nearly see a confidence interval. Okay, so just be careful around that. Then your confidence intervals don't always need to follow the pattern of there's a lower confidence, there's an upper confidence. They might just ask you one of it. Okay, so again, our mind is normally structured that we want to see the lower and the upper as options, but it might just be, and this I've seen in a few papers where they do this, where they just ask you one of the confidence level, so all the upper or the lower, and it can be at your, it doesn't always just need to be with a proportion, it might just be with some of the others as well. Okay, and then there's two nearly what is it, theoretical types of questions. So let's look at this. So when the sample size is 60, the 95% confidence interval estimate for the population is, now they give us 72 point and 101. Then they just go to the next one. So we don't know what the mean is in this question. But when they say, when the sample size is 100, the 95% confidence interval estimate for the population mean is something else. When it's 200, it's something else. When it is 500, it's something else. Okay, so what we're testing here is to say, but let's look at this confidence interval. Okay, so nearly if everything stays the same, so that stays the same in all of them. The Z stays the same in all of them. The only thing that changes is the N. So first 60, then 100, then 200, then 500. Okay, so if you look at this, so if we see 60, that, and let's just say the standard deviation was 100, and if we divide it by 60, let's quickly see what was 100 divided by square root of 60, we get 12 point something. Then if it is 100, it will be 100 divided by 10. That makes it 10. If it's 200, 100 divided by 200 square root. So basically what we see out of this is, so that's around 7. So the bigger n becomes, the smaller your confidence interval becomes. Okay, so as we increase the sample size, the better your prediction becomes. Okay, so this now for me is like, so let's see, so that next one needs to be bigger, that next one needs to be bigger, which it is, that one needs to be bigger, which it is. Let's see, so that one needs to be smaller, which it is. That one needs to be smaller, which it is. That one needs to be smaller, which it is. So just out of that calculation, it tells me that what we are doing is correct. So as the sample size is increasing, the deviation or your range becomes smaller. Okay, so out of that, I'm nearly happy with 1, 2, 3, and 4 that it might be all of them correct. Then there's other simple thing that we can work out. So remember, we've got the lower, we've got the upper, and in the middle, and it seems like here it was 100. So, because if I look at everything, it seems like 100 is sitting in the middle. Another way to work out if these might be right is to add the 2 and divide by 2, then we should get 100. So this is just, it's nowhere in your study guides or anything like that. Probably my answer is going to be none of the above, but let's just check. So 97.7227 plus 102.2773. If we divide that by 2, we do get 100. So 100 is in the middle. 98.236 plus 101.764. Again, 200. So if we divide, we get 100. It will probably be the same for all of them. So that's just, I just want to make 100% sure before I say none of the above that I've done all the checks that is possible to see if they're not trying to catch us with something. So 99.21111 plus 100.7889. Okay, just quickly. 99.2111 plus 100 point, and that's also 200. So 200 divided by 2 is 100. Okay, so for all of these, it feels that it is correct. Working with 95, working with a sample, as the sample increases, the confidence levels will decrease, which is correct. So I would go for none of the above as the incorrect one. So we don't have 100% the information that they told us that 100 is the population mean. We assume it. We assumed a standard deviation, but basically we can then see as, so that is the thing that we need to learn out of this one. As your sample size increases, your deviation becomes smaller. Another way to look at that is very interesting. So let's look at your t values. So as your sample size increases, look at how close it becomes to the standard Z table that we use. So remember, at the 90%, it was 1,645. Look at how close that is. At 99 or 95, it was 1,69, exactly the same. And at 99, it was, let's quickly just check again, what was that? 2,58. So if you round that off, you actually will get 2,58. So again, something that you guys they can ask you in a theoretical question is, as your sample size increase, the more it becomes a normal distribution with a standard deviation that you can say is known. Okay, so that might somewhere come up if they want to really ask it in a theoretical question. So you guys can see the bigger this the sample size, the closer we get to that Z values to say it is normally distributed with a standard deviation that is known. Okay, so let's look at another theoretical one. So that nearly links into, so this came from a previous assignment. So question 3 did this, and then actually question 4 is now, let's look at question 3 and analyze it. So assuming the level of significance stays the same, what happens to the confidence interval estimate when the sample size increases? Okay, so we've now seen in this one, as sample size increases, your confidence interval becomes smaller. It just say becomes smaller. So the same if if a sample decreases, your confidence interval becomes bigger. Way again. Okay, so confidence interval estimate becomes narrower as the sample increases. Let me just show one more thing. So the thing that influences that was, remember, was the standard error. So we said as n becomes bigger, the confidence interval becomes smaller, because that means whatever you're going to divide with becomes bigger. So this answer will become smaller. Okay, so the other way how we can get it to become smaller is if your standard deviation becomes smaller. So if my standard deviation was 10, and let's say whatever I divided it through was 10, we'll see that that confidence interval will be around 1. If my standard deviation now becomes 5, so it becomes smaller, my n stayed the same. Now that becomes 0,5. And if that now becomes 1, it becomes 0.1 or 0.1. But so there's two things that can happen. So if your n becomes bigger, your confidence interval becomes smaller. but also if your standard deviation becomes smaller. So nearly remember, smaller confidence or standard deviation can lead to the smaller confidence interval, or a bigger sample can mean a smaller confidence interval. The same then if your standard deviation becomes bigger, your confidence interval will become bigger. So again, if it was 50, now suddenly it grows by 5. If that was 100, now suddenly it becomes 10. So again, if it became bigger, your confidence interval will also become bigger. So the one that they normally play around with, and I know there's a question that I need to go and look for, is, and let's make a new slide so that we can, let me just, before we end off for today, so I will look for that so that we can incorporate it into one of our prep sessions. So remember, this is the confidence interval. So we already said what will happen when we work with N. We now already said what will happen when we work with the standard deviation. But there's also a Z. So Z90 is 1,645. 95 is 1,96. And then the 99 was, what was it, 2,58, I think. Okay, so that also plays a role on this confidence estimate that you're gonna work with. So the bigger the confidence that we're working with, you can see the bigger that confidence estimate will become. So I know I have a question where they ask about the 90, the 95, and the 99, and which one is correct or not correct. So I will look for you guys for a question or two, again, theoretical question around for confidence intervals, and share it in our next session. Okay, so that was a quick look at confidence intervals. We will do a recap of this on Tuesday, that we just go through a bit more of exercises and things like that. Thursday we'll look at chapter 9, hypothesis testing, and then next week Sunday we will also then do a recap on chapter 9, so that we are then a bit ahead of our schedule for assignment 4, but we'll later on then do a lot of recaps on all the previous assignments and chapters and things like that. Okay, so that is it for today, everyone. I will put the recording up a bit later. I will also